Hello everyone. On this video we will be looking at part 2 of finding the area between curves. Okay, so if you notice on the first video we dealt mostly with linear functions that were pretty straightforward, nothing too complicated. Okay. And also if you remember, none of the functions crossed each other inside the interval. Okay, so what we're going to do on this video is we're going to up it to nonlinear functions, and we're going to see what happens when they cross. Alright, so if you are writing to this, it's consider the region f of x equals negative x squared plus 11x minus 3, and g of x is 5x plus 5. Find the area between the two functions over the interval 2, 4. Okay, now for this one, I gave you the interval, but there are some cases where they won't give you the interval. And if they don't give you the interval, all you have to do is find the points of intersection, and those will be your intervals in most cases. All right. So first, we're going to find your intersection point. Okay, so of course, that's f of x equals g of x. All right, so I'm just going to do that on the side. So f of x is your negative x squared plus 11x minus 3, and your g of x is 5x plus 5. Okay, so we combine our like terms, subtract 5x from both sides. We have negative x squared plus 6x minus 8, when we subtract the 5 from both sides, equals 0. And just to make that lead coefficient positive, we're going to multiply each term on both sides of the equal sign by 1, or negative 1, sorry. So you have x squared minus 6x plus 8 equals 0, which factors to the nice and neat x minus 2, x minus 4 equals 0. So that means you have x equals 2 and x equals 4. So ironically, they intersect at your interval endpoints. Okay, so they don't intersect in between, just right at those endpoints, so you can just go ahead and move forward. So we go with our second step where we pick our test point. And between 2 and 4, I just pick x equals 3. Again, it can be completely random. It's completely up to you. So f of 3, you know that's equal to 21 if you plug in 3 with your x values. I'll let you do that if you don't believe me. And your g of 3 is equal to 20 when you plug in all of your x values with 3. So we know that f of x is greater than or equal to g of x for the interval from 2 to 4. Okay. Again, that doesn't mean it's that way throughout the entire function, but just between that interval, this is true. All right, so what do? We know our f of x is going to appear first. So our area is going to equal the integral from a to b of f of x minus g of x with respect to x. So that's going to equal the integral from 2 to 4 negative x squared plus 11x minus 3 minus your g of x, which is 5x plus 5. Okay. So of course we get all of our combined terms here, so we simplify. So if we simplify everything in there, we end up with negative x squared plus 6x minus 8 with respect to x. So now we go ahead and we integrate each term. So it's negative x to the third over 3 plus 3x squared, that's x squared over 2, 6 divided by 2 is 3, minus 8x, that's from 2 to 4. Alright, so now we go ahead and use our fundamental theorem. So we plug in our 4, so that's equal to negative 4 cubed over 3 plus 3 times 4 squared minus 8 times 4 minus, now we plug in our 2, negative 2 cubed over 3 plus 3 times 2 squared minus 8 times 2. Okay, so we go ahead and simplify, so that gives us negative 64 over 3 plus 48 minus 32. That becomes plus, so it's plus 8 over 3 minus 12 plus 16 once we distribute the minus. Okay, so if we combine our like terms, we combine our fractions, that will give us negative 56 over 3 plus 20 once we combine all of our whole numbers. So that becomes negative 56 over 3 plus 60 over 3 for our 20 to give us common denominator. So that will be 4 over 3 square units. All right. So if you are still writing on this one, feel free to press pause, but we're going to go ahead and move on to our next example. Now for this one, we will see what happens when a point of intersection is inside the interval. Okay, so calculate the area in square units bounded by f of x equals 6x to the third minus 7x squared minus 12x plus 9, and g of x is equal to 7x to the third minus 24x squared plus 58x plus 9 over the interval from 8 to 12. All right, so just like before, first thing you want to do, find your points of intersection. Okay, and you do that with f of x equals g of x, and we solve for x. All right, so we have 6x to the third minus 7x squared minus 12x plus 9 equals 7x to the third minus 24x squared plus 58x plus 9. Okay, so once we subtract 7x to the third and add 24x squared and subtract 58x, we end up with negative x to the third plus 17x squared minus 70x equals 0. The 9's actually cancel each other out. Okay, so again, just to get our lead coefficient to be positive, you can factor it this way if you like. It's just my own little personal quirk. Multiply every term by negative 1. So you have x to the third minus 17x squared plus 70x equals 0. There we go. Move that over a little. There we go. All right, so here we can factor an x out of each term. So if we factor an x out of each term, we have x squared minus 17x plus 70 equals 0. And that gives us a nice, neat little factor of x minus 7 and x minus 10 for that trinomial equals 0. Okay, so To make this true, that means either x equals 0, x equals 7, or x equals 10. So honestly, if you look for your interval from 8 to 12, x equals 0 and x equals 7 are not in that interval. So we don't even have to worry about those. This is the only one that's inside the interval. From 8 to 12. Okay, so this is how we're going to have to handle that. Because what happens is, when you get to x equals 10, those two functions cross each other. So when they cross each other, that means where f of x may be bigger than g of x, now g of x is bigger than f of x in that interval. Okay, so if we go from 8 to 12, let's say if we put our 8 here and our 12 there, and it intersects at x equals 10. Okay, so what we have to do is we have to find a test point between 8 and 10, and we have to find a test point between 10 and 12. Okay, so between 8 and 10, we'll pick x equals 9. Okay, so f of 9, if you replace x with 9 in your f of x, I'm not going to go through all of that, but it's 3,708. And your g of 9 is equal to 3,690. So this tells us that f of x is greater than or equal to g of x between 8 and 10. And now, between 10 and 12, x equals 11. Okay, so f of 11 is equal to 7,016, and g of 11 is equal to 7,060. So in this case, g of x is greater than or equal to f of x. For the interval from 10 to 12. Okay, so since they switch up, the integral from 8 to 12, just kind of give you an idea of how we're going to approach it, we're going to separate it because now these two switch up. We're going to make that the integral from 8 to 12, where f of x is greater than or equal to g of x, plus the integral of 8 to 12, 8 to 10, sorry about that. Thinking ahead before I'm done writing. 8 to 10, plus the integral from 10 to 12, where g of x is greater than f of x. Okay, so if you're still writing, feel free to press pause, but we have run out of space on this page, so we're going to go ahead and continue on the next page. So if you're writing, feel free to pause and finish up, but we're going to go ahead and move on. Let me get a clean sheet here. Okay, now for the interval from 8 to 10, where f of x is greater than or equal to g of x, you're going to have f of x minus g of x. Okay? And you could go ahead and simplify that inside, but I'm kind of doing it ahead of time. And again, if this process doesn't work for you, don't worry about it. You can use your own. But this is just how I do it. My f of x minus g of x is 6x to the third minus 7x squared minus 12x plus 9 minus 7x to the third minus 24x squared plus 58x plus 9. So if we distribute our negative and combine all of our like terms, we end up with negative x to the third plus 17x squared minus 70x. Remember, this is just your f of x minus g of x. Now, for the interval from 10 to 12, remember that's g of x minus f of x. Where g of x is greater than or equal to f of x, g of x minus f of x, that is 7x to the third minus 24x squared plus 58x plus 9 minus 6x to the third minus 7x squared minus 12x plus 9. Okay, and again, once we distribute our negative and combine all of our like terms, we end up with x to the third minus 17x squared plus 70x as our g of x minus f of x. Okay, so our area is going to equal the integral from a to b when you have a point in the graph where your point of intersection is inside the interval. That is your absolute value of f of x minus g of x with respect to x. Because you're going to get that and you're going to split it up. Okay, now if you remember the process for finding the integral of an absolute value, then this makes sense. If not, then definitely go back and look at that, and it will, or as a refresher, and it will definitely clear that up a little bit as to why that becomes the absolute value of that, of the two functions. Okay, so that's just the integral from 8 to 12 of f of x minus g of x with respect to x. Okay, now, of course, since the functions intersect at x equals 10, that becomes the integral from 8 to 10 of f of x minus g of x with respect to x, plus the integral from 10 to 12 of g of x minus f of x with respect to x. Okay. Now again, if you wanted to come right here and solve your f of x minus g of x and g of x minus f of x here, you could. I just didn't want all that space filling up. That's why I did these ahead of time. So this is going to be the integral from 8 to 10. Our f of x minus g of x. Remember, that's right here. We already did that ahead of time. So negative x to the third plus 17x squared minus 70x with respect to x. plus the integral from 10 to 12, our g of x minus f of x, we did that ahead of time, as x to the third minus 17x squared plus 70x with respect to x. Okay, so now we go ahead and we integrate each term. Okay, so we have negative 1/4 x to the fourth plus 17 over 3x cubed minus 35x squared. And again, that's from 8 to 10. Plus, integrating each of those terms, we have 1/4 x to the fourth minus 17 over 3x to the third plus 35x squared. That's from x equals 10 to x equals 12. Okay, so after applying the fundamental theorem to both, you actually end up, this will become 88 over 3, and this will become 206 over 3, which is 128 square units. All right, so you're kind of running out of room there, so I figured you can go ahead and apply the fundamental theorem of calculus on your own. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. All right. So consider the region bounded by f of x equals 8x to the third plus 7x squared plus 28x plus 6, and g of x equals 7x to the third minus 6x squared minus 8x plus 6. Find the area between the two functions over the interval -2 to 2. All right, so what I want you to do is go ahead and press pause and use the process on the previous example because it did not change. And I want you to go ahead and try to solve this one on your own. All right, so I'm going to go ahead and assume that you have pressed pause and you have worked this one out. So let's go ahead and verify. So first thing you're going to do, just as always, find your points of intersection. Okay, basically just the points where those two graphs cross each other. Okay, and to do that, make f of x equal g of x. So that gives you 8x to the third, clean that up a little, plus 7x squared plus 28x plus 6 is equal to 7x to the third minus 6x squared minus 8x plus 6. Okay, so once we get done subtracting 7x to the third and adding 6x squared and adding 8x and subtracting 6, we will end up with x to the third plus 13x squared plus 36x equals 0. And from there, we're going to go ahead and factor an x out of each of those. We have x times x squared plus 13x plus 36 is equal to 0. And we go ahead and factor that trinomial in there. So you have x times x plus 9, x plus 4 equals 0. So we know for this to be true, x has to equal 0, x has to equal -9, or x has to equal -4. Now, between -2 and 2, -4 and -9 is not in that interval. X equals 0 is the only one that's in the interval of -2 to 2. Okay. So we go to our trusty number line to make sure we don't mess anything up. So we have from -2 to 2. So -2 to 2. And x equals 0 is when they cross each other. So that means our integral is going to go from -2 to 2 to -2 to 0, then 0 to 2. So first, we have to pick a test value between -2 and 0. And we have to pick test value between 0 and 2. Oh, there we go. Okay. So let's say for this one we pick x equals -1. And for this interval, of course, we pick x equals 1. They just seem like the logical choice for random test values. So that means for x equals -1, f of -1 is going to equal -23. Again, you can plug in -1 to your f of x and figure all that good stuff out. And g of -1 is going to equal 1. So we know that g of x is greater than or equal to f of x for the interval -2 to 0. Okay. What about our x equal 1? Well, our f of 1, again, you plug in 1 into your f of x, you'll get 49. And our g of 1 is -1. So that means that f of x is greater than or equal to g of x for the interval from 0 to 2. That means when we calculate our integral, instead of going from -2 to 2, we're going to go from -2 to 0, where g of x is greater than or equal to your f of x, plus the integral from 0 to 2, where f of x is greater than or equal to g of x. All right, so we are running out of room on this page. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next page. Okay. So for the interval from -2 to 0, where g of x is greater than or equal to f of x, we know that you have to use g of x minus f of x. So g of x minus f of x is just 7x to the third minus 6x squared minus 8x plus 6 minus your f of x, which is 8x to the third plus 7x squared plus 28x plus 6. Okay. Now once we distribute our negative and combine like terms, that will equal -x to the third minus 13x squared minus 36x x. Remember, that's just your g of x minus f of x. All right, now for the interval from 0 to 2, where f of x is greater than or equal to g of x, we know we have to have f of x minus g of x. Oh, let me clean up that g. There we go. Now, f of x minus g of x is just 8x to the third plus 7x squared plus 28x plus 6 minus 7x to the third minus 6x squared minus 8x plus 6. And again, once we distribute our negative and combine all of our like terms and all that good stuff, that will equal x to the third plus 13x squared plus 36x. Remember, that's your f of x minus g of x. Uh-oh. Okay, so we have both of those ahead of time. Okay, so our area is going to equal the integral from a to b, and since our graph or our functions are crossing on our interval, it's going to be the absolute value of f of x minus g of x with respect to x. So that's really just the integral from -2 to 2 of the absolute value of f of x minus g of x with respect to x. Okay. And again, since the functions intersect at x equals 0, this becomes the integral from -2 to 0. We know on that one g of x is bigger than f of x, so it's g of x minus f of x with respect to x, plus the integral from 0 to 2, where f of x is bigger than g of x. Okay. And once again, we did our g of x minus f of x ahead of time. So we have the integral from -2 to 0 of negative x to the third minus 13x squared minus 36x with respect to x, plus the integral from 0 to 2 of f of x minus g of x, which we did ahead of time, x to the third plus 13x squared plus 36x with respect to x. All right, so now we can go ahead and integrate each one of those terms. So this becomes -1/4 x to the fourth minus 13 over 3x squared, x to the third, sorry about that, minus 18x squared, and that's from -2 to 0, plus, I should go ahead and close that, 1/4 x to the fourth, or x to the fourth over 4, plus 13 over 3x to the third, plus 18x squared, and that is from 0 to 2. Okay, now for each of those, you're going to apply the fundamental theorem of calculus, where you're going to plug in your 0 and then the -2. Then you can plug in your +2 and your 0. And when when you do that, you should end up with 124 over 3 plus 332 over 3, which is equal to 152 square units. All right, so that's how you find the area between two curves when your point of intersection is outside the interval, as in the first video, and inside the interval, as you've seen here. All right, so hopefully, once again, hope this made sense, and I will see you on the next video.